Lesson C 6.2, questions on pages 11 to 13. Let's go through these. Refer to what you've learned in the lesson to complete the table below. Solution in water. So immediately you know, because it's a solution, we've got water present, so we've got H plus and we've got OH minus ions in there as well. So potassium bromide solution contains 4 ions, potassium and bromine from the substance itself, and H plus and OH minus from the water. What do you get? At the negative electrode, you attract H plus ions, so you get bubbles of hydrogen. And at the positive electrode, you get bromine. You always get the halogen coming off first. So bromine is a halogen, orange-brown liquid, and bromine there. Depending on the temperature, it may come off as a gas if it's warm enough. Sodium sulfate, we have 4 ions again. Sodium and the sulfate from the substance, and H plus and OH minus from the water. We get bubbles of hydrogen because hydrogen is less reactive than sodium. So hydrogen is given off first. Same as up here, hydrogen is less reactive than potassium, so hydrogen is given off first. And then bubbles of oxygen because there is no halogen, so oxygen is given off by the OH minus. Last one, copper chloride. We have copper 2 plus ions. We know it's 2 plus because copper 2 in Roman numerals there. Okay, so that gives you a clue as to the charge on the ion here. Cl minus, chloride, and water. You get a red-brown coating on the cathode. Now this happens because copper is given off. Copper is given off because copper is less reactive than hydrogen, so copper is given off first here. And then we get a yellow-green gas or bubbles given off, and that's chlorine because we have a halogen present. Halogen is given off in preference to everything else there. Okay, question 1. Which of the solutions contain metals that are more reactive than hydrogen? And the answer is potassium bromide and sodium sulfate. So potassium and sodium are more reactive than hydrogen. Which solutions contain halides, potassium bromide, and copper chloride? Complete the following sentences. In the aqueous solution, aqueous meaning in water, dissolved, water molecules break down and they produce H plus ions and OH minus ions. An equation with state symbols to show how water breaks down. H2O, liquid, breaks down into H plus aqueous because it's now dissolved, and OH minus dissolved. At the negative electrode, the cathode, hydrogen is produced if the metal is more reactive than hydrogen. At the positive electrode, the anode, oxygen is produced unless the solution contains halide ions, in which case the halogen is produced. Chlorine, bromine, iodine, fluorine. Okay, moving on. State how, question 4, you would test for the presence of the following gases. This comes up quite frequently and it's worth learning these. So hydrogen, a lighted splint gives a squeaky pop. Oxygen will reignite a glowing splint. And chlorine turns litmus paper white. Brine is a concentrated solution of sodium chloride. Write the ions that are present in the beaker to the right. Sodium and chlorine from sodium chloride, H plus and OH minus from the water. Remember, it tells you here it's dissolved in water, so you add water's ions as well. Write an overall word equation for the electrolysis of brine. This is me not reading the question correctly because it says word equation. I've written a symbol equation. But we have sodium chloride, aqueous, dissolved, plus water, liquid, produces hydrogen gas, chlorine gas, and sodium hydroxide, which is aqueous dissolved. Explain why this is an important industrial process. It's because it produces 3 valuable substances: hydrogen gas, chlorine gas, and sodium hydroxide. They can all go on to be used in other processes. So hydrogen here, for instance, can be used to make margarine. Chlorine gas can be used as a disinfectant and to make bleach. Sodium hydroxide can be used to make soap. D. Explain why hydrogen is produced at the cathode. Hydrogen is less reactive than sodium, so it's given off first. So we go back to that rule of solutions. E part 1, explain why sodium hydroxide is left in the solution. Well, the hydrogen and the chlorine are removed as gases, and it leaves sodium hydroxide in the solution. So if you look here, we take away the hydrogen and the chlorine. We're left with sodium hydroxide. Predict what you see if you tested the solution with universal indicator. Well, universal indicator will turn purple because sodium hydroxide is a strong alkali. Question 6. Predict the products when the following aqueous solutions, so this is telling us water is present, are electrolyzed. Use the reactivity series to remind you which metals are more reactive than hydrogen. So potassium is more reactive than hydrogen. So hydrogen is given off at the negative electrode. Chlorine is a halogen, so it's given off first at the positive. Copper is less reactive than hydrogen, so it's given off first. And oxygen is given off because there is no halogen present. There's only copper nitrate here. Magnesium chloride. Magnesium is more reactive than hydrogen, so hydrogen is given off. And chlorine is given off because a halogen is present. Silver nitrate. Silver is less reactive than hydrogen, so silver is given off here. And oxygen is given off because there is no halogen present. It's worth noting here that copper and silver are given off as solids, so they will coat the negative electrode. They will effectively electroplate it. Question 7. Complete the following sentences. During electrolysis, at the cathode, positively charged ions gain electrons. So this is a reduction process. And at the anode, the positive electrode, negatively charged ions lose electrons, and so this is an oxidation reaction.